The following program is brought to you without commercial interruption, thanks to Sprint.
I've been exploring the wireless world of Sprint, and I've learned Sprint is building America's mobile 5G network. Sprint, a brighter future for all.
Illusions hold a very special place, in part because they're so surprising. You take a look at them and you expect to see one thing and something else happens. They tell us something deeper about our perceptual world and what it is we see. And that's a big question, because the question that we see something, that we see colors, we see objects, is something that we take for granted, but it really is a deep philosophical problem that has plagued or sort of been a central question for humanity since we've started thinking about what we are and who we are and what we do. So the real question is about reality and the nature of how our brains interpret reality. Here, there's a single dot traveling back and forth on a straight line. Now I'm going to add another dot, so there are two dots traveling on a straight line. And here are 6 dots, all traveling on straight lines. If I change the phase of the orange dot is still traveling on a straight line, still traveling in a straight path. And the red dot, again, still in a straight path, same timing as all the other dots. It's just that the phase of its modulation is different. Here's the purple dot, the yellow dot, and the green dot. Now, if we move the guides, we can see that the dots are organized to form a circle. So each dot by itself would be seen as traveling on a straight line. But taken together, all the dots are traveling as something more than what you would expect to see, traveling as a circle, moving around. So in the Tuesday illusion, we have a conflict between a dot that moves in a straight line and the society of dots. So that's how the dots are organized. But conflicts like this exist all over the place. For instance, in the wagon wheel illusion, which is something everybody's seen, I'm sure you see an old movie with a stagecoach and the stagecoach starts moving off one direction, but the wheel looks like it's spinning in the opposite direction. Well, if you play games with that type of illusion, you can start seeing how there's conflict embedded even in the simplest of image. Here we have an example of the wagon wheel illusion. There are 5 rings, each with 12 dots. The dots are separated by 30 degrees of angle. If we start to rotate the ring, it starts moving slowly in a clockwise direction. If we go faster, at 15 degrees, it's as if the direction of the ring can't make up its mind. Now, if we move the ring a little further, the ring starts going backwards. And if we go faster still to 30 degrees, the motion actually stops. And that's because it's always ambiguous. In this case, even though the ring is always spinning in a clockwise direction, each dot moves and falls on top of the other dot. And when that happens, the visual system has to make up its mind. Is it rotating clockwise? Or is it standing still? And of course, standing still is a much simpler explanation, so you don't see its motion. If we were to move it at 27 degrees in one direction, that's the same as moving 3 degrees in the opposite direction. It's ambiguous. The visual system has to make up its mind. And it chooses to go, choosing, of course, being a rather funny term for this, it perceives the motion going backwards because it's a simpler process. We can play games with the ambiguity by changing the color of the dots because that gives away the game. So here, one of the dots in each ring is yellow. When we start moving it forward, you can always see the direction of the yellow dot. Here we go at 5 degrees in the clockwise direction. All the dots are moving together. At 15 degrees, that was when the ring could be going clockwise or counterclockwise. In this case, we see the yellow ring always going in one direction, but we can't really pick out which direction the black dots are going. As we go faster, the separation begins. The black dots start going backwards. The yellow dots start going forwards. The Toozy illusion and the color wagon wheel illusion show a conflict between two different sorts of information. So in Toozy, it's dot traveling in a straight path versus grouping as a circle. And in the color wagon wheel illusion, it's showing motion for change detection versus feature tracking. There are other illusions which combine more than one features. Some of my favorite illusions are ones which combine multiple features and multiple types of conflict in the environment, or tap into different processes in the brain. And the combination of the effects often creates really compelling illusions that everyone likes to look at. Here is Jeremy Hinton's Lilac Chaser. It's a wonderful illusion. There's no real motion here. All you're seeing is a dot turning off and turning back on, but it creates the impression of a dot traveling around the circle. In addition to that, when the magenta dot turns off, you are left with a green afterimage. That green dot is entirely constructed in your brain. Then the third illusion is something called Troxler fading. And this one takes a little practice. But if you fixate directly at the center of the screen and make sure you keep your eye as steady as you possibly can, then the pink dots will start to fade into the background as if they're not there at all. And that relies on the idea that in order to see things, we have to have edges. Your eyes have to move across edges. And if you get rid of those edges, then things begin to fade. The game is both to create these types of conflicts that make it really compelling to look at, and then try to narrow down the different conditions so that we can understand the processes that underlie them. Well, here's an illusion which shows that just because you sense something doesn't mean that you will perceive it. I just love this illusion, referred to as motion-induced blindness. It is a truly compelling illusion, and the first time you see it, it's hard to believe that it's actually happening. If you stare at the green dot in the center, you will see something remarkable happen. You should start seeing the yellow dots disappear. The dots are always there. They're always making an impression on your retina. There's always light coming from there, reaching back your eye, and your rods and cones are picking up the light, and they're turning into a signal that your brain can interpret. But for some reason, possibly due to attention, the dots just go away. They're just gone, and it's really compelling. So, do you know why this happens? I don't either. One would think that the easiest thing that we could explain was how bright an object is, right? The light comes in, the more light that goes to our brain, the brighter the object looks, right? Turns out that's not so simple. And next time, we're going to talk about different illusions which play games with how the brain constructs the perception of brightness. So for example, here's Ted Adelson's famous checker shadow illusion. We have two squares, one labeled A, one labeled B. A is dark, B looks light. But if you were to put the two squares right next to each other, you would see that they are identical. How can that be?
Watch more free episodes at curiositystream.com.